Today is Monday, March 16th. As fourth period pointed out, it's the day before St. Patty's Day. We're in fifth period, Algebra II with WSSB. We are currently going to embark upon section 6-4, which is completing the square. Now, last week we learned how to solve equations by A, graphing, and B, factoring. This is a similar idea. This is just another way to solve for the roots. Now remember, the roots of a quadratic equation occur when the parabola touches the x-axis. We call them the roots, the solutions, the zeros. Okay? So today is the reason why we call them roots, because you're finding square root stuff. So I want to remind all of you again that it's just a process. Kind of like when you learned how to add and subtract fractions. Okay? It's just a process you have to learn and get through. Solve it. That's it. So it might be a little rocky at first. I encourage you to write down the steps that you have to do to complete the square, and they're also going to be in your book. I'm at the top of page 306, and it says what we'll learn is solve quadratic equations by using the square root property. Solve quadratic equations by completing the square. That's what we're hopefully going to figure out how to do today. And the cough is still here, but it's just like holding on for dear life.
That sounds bad.
It won't let go. But it's definitely not as bad as it was. I could talk for more than 2 sentences without hacking in your guys' ears. So I'm grateful for that. Alright, so Thursday we learned about the zero property, which is if you have two numbers A and B and they equal 0, that means one of them or both of them are equal to 0. Because anything times 0 is always 0. Well, today we're using what's called the square root property to solve quadratic equations. So I'm halfway down the page below why we use this. Because again, it's just another method of solving quadratics. So there's all these capital words that say square root property. Okay. So far, you have solved quadratic equations like x squared minus 25 equals 0 by factoring. That one's pretty easy. That's the difference of squares. You can also use the square root property, all in fancy bold letters, to solve such an equation. This method is useful with equations like the one above that describes the that describes the, I thought it said race, and it really does. Oh yeah, the race cars from the example above. Speed. Okay. In this case, the quadratic equation contains a perfect square trinomial set equal, and then set equal to the constant. What on earth are they talking about? Well, let's find out in the key concepts box. Okay. Fixed it, fucker. For any real number n, if x squared equals n, then x equals plus or minus the square root of n. It's fixed. And we're recording, FYI.
Oh. Do you have Maria's?
I don't. You have to type her into the search box.
Yeah.
Didn't work?
Not in yours. Okay.
Okay, sorry I couldn't be any more help. So, like 3 squared equals 9, right? Or 3 squared equals this. So if x squared equals 9, right, you got to solve by square rooting both sides. You would get x equals the plus or minus the square root of 9, okay? Because again, negative 3 squared is 9, and positive 3 squared is also 9. And what they're saying is when you square stuff, you're going to have a positive version and a negative version. Remember that from before? Last chapter, everybody's favorite chapter. Right, Ella? She's not even talking because she's mad at me and she's sick because I got her sick. Oh well. Alright, let's look at example 1. Example 1, right below the little key concepts, called equations with rational roots. Rational. Anyone know what that word means? terms of the number line?
Isn't it like a fraction?
Well, a fraction or a whole number, right? Because can't every whole number be written as a fraction?
Yeah.
Yeah. So 6 over 1, 2/3. Well, 2/3 is actually irrational. Scratch that. 3/4. Because 2/3 is 0.33333 repeating. Okay? Or 666. 66. All right. Example 1. I had to make sure I didn't say 3 of them. All right. So x squared plus 10x plus 25 equals 49 using the square root property. Now again, this can be factored into a square, can't it? What multiplies 25 and adds up to be 10?
Oh, 5 and 5.
Yeah, exactly, Stormy. So you can rewrite this as open paren x plus 5 close x plus 5 equals 49, also known as open paren x plus 5 close squared, right? Because there's 2 of them.
Mm-hmm.
So when you do this, okay, then if you have a square, we learned from last chapter, what do we got to do to get rid of the square? We got to root both sides, right? So what's the square root of x plus 5 squared?
X plus 5.
Exactly. Equals plus or minus the square root of 49. Because again, according to the square root property, you have a negative version and a positive version. Okay. Can we do something with the square root of 49?
Mm-hmm.
Yeah. What's the square root of 49?
7.
Right. So now you have x plus 5 equals plus or minus 7. Okay? So now, you've got to get rid of that 5 on both sides by subtracting.
Mm-hmm.
So the way you do this in pretty math land is you put your negative 5 in front of the plus or minus sign. You get x equals negative 5 plus or minus 7. We say that little sign needs plus or minus because we could do either one. So the answer is x equals negative 5 plus 7 and x equals negative 5 minus 7. Okay? That's what that plus or minus sign means. You do the first one and then you do the second one.
Oh, okay.
Yeah. So x equals negative 5 plus 7, which turns out to be positive 2, and x equals negative 5 minus 7, which turns out to be negative 12. So you just factored it into its perfect square, and lucky you, it was x plus 5 squared. And you take the square root of both sides, and don't forget the plus or minus sign. You're going to miss one of the solutions, aren't you?
Yep.
You don't want to miss one. Okay? And then you put your solutions in braces, if you like. 2, comma, negative 12, close brace. Okay? Anybody have any questions about that part? This isn't even completing the square. We're not even there yet. Can everybody do it yet? Do you think so? You
Yeah.
All right. We'll go with that. Very bottom of the page. Roots that are irrational numbers, such as 0.33333, aka 1/3. I want to stay away from 2/3 for a while now. Roots that are irrational numbers may be written as exact answers in radical form, or as an approximate answers in decimal form. Out of paper? When the calculator is used. Okay. Okay. Now, equations with irrational roots. Now, if you're not going to use the calculator, you can leave it. Okay? If you know how to use the calculator, go ahead. Find out. Okay? I really don't mind. Either way, I actually, one of these days, am going to spend another day with the calculator, but that's when everybody's here. Okay? I really want to spend more time with the calculator because it's a really cool tool. Alright, I'm at the top of the next page looking at example 2. Okay. Solve x squared minus 6x plus 9 equals 32. You should think, oh, looks like a square. What multiplies to be positive 9 and adds up to be negative 6?
3 and 3.
You're right, except Josiah helped you out and said negative 3 and negative 3, right?
Yeah.
Yeah.
Mm-hmm.
So then you could rewrite the whole thing as x minus 3 equals 32, also known as open x minus 3 squared, close squared, equals 32. Same process, How do we undo the squaredy?
Square root of it.
Uh-huh. You're right, Stormy. And then it says x minus 3 equals, what's that thing you always have to remember to put there?
Plus minus.
Plus minus the square root of 32. So let's think about this. Is the square root of 32 a perfect square? Is there?
No.
No. Nope, you're right. It is not. Okay. So let's first move that. So what they did is you can simplify it first. How can we simplify square root of 32? What can come out? This is where chapter 5 comes in handy. What can we pull out of 32?
Oh, just thinking. Oh, a 4.
Well, how would we rewrite it first so that we don't skip a step? Okay. How can we break up 32 into a perfect square times something? Excuse me.
What is it?
Anybody? Stormy's thinking I know that, but you two over there, I never know what you're doing. Break out 32. No. Before you pull it out. What's the perfect square?
Not in half. 4 and...
Doesn't matter, 4 and 8. She didn't say. She just said divided.
Not 4 and 8. Nope. Ella, do you have any ideas? What's that perfect square that goes into 32?
Oh, Mrs. G, you're wrong. I would have did 4 and 8.
Oh.
What? 16!
I have it.
Hey! Somebody has it. Right. It's 16. Okay. So again, you can break that up into the square root of 16 times 2. Right?
Yeah.
Okay. That's where the 4 comes
No,
from. That's why I didn't want to skip steps. I wanted to make sure everybody understood where it came from. Okay. So you break it up into the square root of 16 times the square root of 2. Well, what is the square root of 16?
4.
4. So then, when we move that negative 3 over, we got x equals 3 plus or minus 4 square root 2. Okay? So this is why chapter 5 was so handy, right?
Mm-hmm.
The square root of 2 is an irrational number, and they made me prove it in college, just so you know. I had to sit there and write a whole page with math theorems to tell you why the square root of 2 is irrational. That's the first proof you ever learned. And it was horrible. Okay, so then you can use your calculator to figure it out. 3 plus 4 square root 2 and 3 minus 4 square root 2. Now remember, 4 square root 2 means 4 times the square root of 2, whatever that might be. Okay? So the book says it's approximately, for the plus one, it's approximately 8.7, and for the minus one, it's approximately negative 2.7.
You mean it's times.
So you could leave it 3 plus or minus 4 square root 2, and then tell me the two different solutions. X equals 3 plus 4 square root 2, and x equals 3 minus 4 square root 2, so that I know that you understand that they are different. Okay? Separate them. And then, of course, they check it. And they use the calculator to do it. Cheaters. Okay? So again, it's mathematically correct to leave it as 3 plus or minus 4 square root 2, and then to separate them. Okay? It's more precise, actually, because you're not rounding. Okay? That's my professional opinion, anyway. Alright. Does everybody understand how that stuff goes? Because it's really important, because that's how this is why we complete the square, is because of the last two examples. Okay? You ready to figure out what on earth completing the square is? Okay.
Sure.
Alright. The square root property can only be used to solve quadratic equations when the side containing the quadratic equation or expression is a perfect square. Right? Because we want to make it in such a way where it's open paren something closed squared. Right? The only way we were able to solve these things. However, few quadratic expressions are perfect squares. But we can make one to make a quadratic expression a perfect square, a method called, look at that, completing the square, may be used.
Did you find
Do
it?
a little example, okay, of why this works. In perfect square trinomials, there is a relationship between the coefficient of the linear term, the x term, okay, and the constant term. Now remember, it was something that was doubled to add up to be the middle term. That's the relationship. Because remember, if we had 3 times 3, that added up to be -6. If we had 5 times 5, that added up to be 10. Same concept. If you could multiply it by itself and it adds up to be the middle term, that's the relationship they're talking about. And then here it goes. Consider the pattern of the squaring a sum. Okay. X plus 7 squared. They FOIL it out for you. Okay. X squared plus 2 times 7 plus 7 squared. Because again, 2 times 7, you're adding the 7s twice. Right? Multiplying is nothing more than repeated addition. Then you get x squared plus 14x plus 49. And then they show you that 14 over 2 squared equals 7 squared. Comes from 7 squared. Yep. When you divide them. Okay. So this is where completing the square comes from. It's a way of making sure the c term, when multiplied together, will add up to be the middle term. Now, they have these pretty steps right here in the key concepts box. I would like all of you to write them down. Even if they don't make any sense to you, you're going to have to refer back to them.
Okay.
I would write them down and I'll read them. You can use this pattern of coefficients to complete the square. Okay? A quadratic expression. Okay? They leave it in ax squared plus bx plus c terms. So if you like, instead of writing them with a, b, and c, we can use an example. What do you think?
Yeah.
Find 1/2 of the middle term. That's step 1. I'm just going to say them anyway for now. Find 1/2 of the middle term, the b term. Square the result. Add the result to step 2.
Yeah, I'll click it.
No problem. I'll repeat it. Okay.
Okay, what was it? Find 1/2 of the term.
Find 1/2 of the middle term, so b, in the form ax squared plus bx plus c. Find half of it. Half of b. Half of the middle term, whichever way you prefer to remember it. Excuse me. Okay, that's step 1. Find half of the middle term. Square it. Square that thing you just found. That part. So half of 6 would have been 3. We would have squared it. Okay. So step 1, find half of the middle term / the b. 2, square that, whatever it is. Okay. 3, add the result to the equation x squared plus bx. That is, add it to the end of your equation.
You want me to repeat anything?
Yeah, please.
Add the results of step 2.
Whatever that square is, stick it on the end of your empty quadratic where the c term used to be. See what it's saying.
Step 2.
Mm-hmm.
2 TL x squared plus bx.
Yep. Hey.
Okay.
So example 3 is just finding the value. So whenever you're ready. Okay?
It's in your book too. It says.
Example 3, okay.
Okay. Now they leave it blank for you. Lucky you. Okay, in example 3, they left the c term on its own. They want you to find it. by using the method of completing the square. Okay? Let me know. Are you ready, Stormy?
Yeah.
All right. So, find the value of c that makes x squared plus 12x plus c a perfect square. Okay? Then, write the trinomial as a perfect square. Then that means separate it into its parentheses. Okay? So, what's the first step?
Find 1/2 of thing.
Right, so what's b?
12.
Okay, what's half of 12?
6.
6. That's step 1. You just did step 1. The answer is 6. What do we do in step 2?
Where's the result of step 1?
Right, so what's 6 squared?
36.
Okay, so you just found the answer to step 2. You squared the result in step 1 and got 36. So what do we do? Where do we put it?
X squared plus 12.
Nope. You got to add it to the bx term. Okay? That's 12x stays there too. So it's x squared plus 12x plus
36.
Exactly. Okay? Now you found how to complete the square. You now have a perfect square trinomial. That is x squared plus 12x plus 36. So how do we factor this for the second part of what they want in this answer?
Oh, you got them?
Mm-hmm.
Did you write it down, or did you follow along?
Yeah, I'm following.
The x squared plus 12x plus 30.
Yes.
Okay, now
The whole reason we're doing this is to separate it into a certain way, right?
Oh. 6 and 6.
Right. So how do we write that in parentheses and stuff?
Plus, x plus 6 squared.
Exactly. Open paren, x plus 6 squared. That's what we want if we were solving an equation, because then we can square root both sides, right?
Yeah.
Okay. It's not as scary as you thought, huh?
Mm-mm.
So again, step 1, find half of the middle term. Find half of b. Step 2, square that, whatever it is. Step 3, add it to the end of your ax squared plus bx to make a full parabola equation. Then factor it into blah, 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 parentheses squared. Whatever it could be. It could be 6, it could be 9, it could be anything. Well, the whole reason we're doing this process is so we can have an open paren x plus something closed squared. Okay? Anybody have any questions about the process of this?
Not yet.
Good. Well, let's skip the calculator portion for now. It's a little algebra activity thing. You can do it with blocks, which is actually kind of neat. That's what it's saying. And look at example 4. Okay. Now we're actually going to solve one of these suckers using the quadratic formula. I'm jumping ahead. Solving by completing the square. Okay. Example 4. Here we go. Oh my gosh. Crazy town. Alright. Solve an equation by completing the square. Alright. Did you find it, Stormy?
Yeah.
Okay, just checking. Solve x squared plus 8x minus 20 equals 0 by completing the square. Now remember, in order to start completing the square, we can't have a c term, can we? We want an x squared plus bx thing going on, don't we? Okay? So you've got to get rid of that negative 20. How do we get rid of a negative 20?
Plus it.
Right. So then you got x squared plus 8x equals 20. That's fine, right? Now we can start completing the square. It's just you have to remember we are in algebra land. So whatever you do the left side, you have to do the right side. First of all, what's step 1?
Find the b term.
Well, find what a b term?
Oh, half.
Half of b. What is half of b?
4.
4. Step 1. Now what's step 2 say? Just square
square
it.
it.
Creepy, whispery voice. Square it. What's 4 squared?
16.
16. Then what do we do with it?
Put it into the
Two.
formula.
Yeah.
Both sides.
But remember, we're adding 16 to the left side of the equation. What do you think we got to do to the right side?
Add it.
Right. So you get x squared plus 8x plus 16 equals 20 plus 16. Does that make sense?
Yeah.
Yeah, because you can't just change one side of the equation. That's a big no-no we learned in pre-algebra, right? Well, 20 plus 16 is 36. Okay, so you could just say x squared plus 8x plus 16 equals 36. But now we can factor, can't we? How can we turn x squared plus 8x plus 16 into the form we want?
Oh, 4 and 4.
Right. So you would have open parens, x plus 4 close squared equals 36. How about that? We did it. That's what we want, right? So what do we do to both sides? We're at the very last line of the page. Okay. What do we do when we have open x plus 4 squared equals 36?
Oh, solve them.
Right, by what do we do first? To get rid of that squared.
Square them.
Exactly. So the left side, the parentheses just drop, right? We get x plus 4. What about the right side? Well, yeah.
Yeah,
Plus or minus square root of 36. And Josiah skipped a step and said, oh, well, that's plus or minus the square root of 6.
Yeah.
I would like you to say all the steps because we're learning. It's important. Especially because you never speak up. I'm actually really proud of you right now for saying stuff. All right. So, x equals, and we got to move that stupid 4 over, right, by subtracting it. Negative 4 plus or minus 6. And then you do each one separately. Negative 4 plus 6 is?
10.
Negative 4 plus 6?
Oh, I know it.
Wrong way.
I know it's no negative.
Yep.
2.
2, and then negative 4 minus 6. Now you can say it.
Minus. Oh, negative 10.
Right. So then you've got the answers. X equals 2 and x equals negative 10. You can write them that way or put them in braces. Either one is fine with me. How do you feel about that? There's 2 extra steps in this example. If you have a C term, you have to move it over before you can start completing the square. And once you find the value you need to complete the square, right, you have to add it to both sides of the equation. Don't forget to add it to the other side. Otherwise, you will be wrong. Okay? Because in algebra land, whatever you do to one side, you have to do to the other. Okay. Let's just not do the ones. How do you guys want to just practice today? We'll do the last 2 examples tomorrow. Okay?
Yeah.
Because tomorrow it's when there's a coefficient in front of x squared. Okay? So for today, I'm just going to give you all the ones that have no coefficient. So that's 4. Definitely not 5. 4. And 6. 7. You're going to get a fraction, but that's okay. 4, 6, 7, 8, 9. Hold on, I'll be more clear in a second. 10.
What page?
Sorry, page 310. So, you can do 4, 6 through 10, and 4, 6 through 10, and 14 and 15. Or 6 through 10 and 14 and 15. I had to basically just skip the ones with coefficients and skip the word problem. I want you to get really good at this process. When I was your age, I didn't want to care about it. So I'm going to make you guys care. Because I, still to this day, I'm like, oh yeah,